Good morning. I'm going to give this talk now on a bit of chemistry. My son is doing this at school and he doesn't understand it. So I figured it out from this morning. I'm not a chemist, so I hope my language works out okay. If you're not particular or from a particular field, the language sometimes sounds different. I'm a physicist, but I should be able to deal with this because it's not rocket science, okay? It's dead easy. But some people have a way of complicating things. To figure something out, you have to bring it down to its essentials. So we're going to learn about molarity and pH, to cut a long story short. I'm going to have a talk on, well, this is to do with solutions. It involves moles, molarity. That is really concentration. pH, what does it stand for? Potential of hydrogen. POH, potential of OH. Acids and bases generally. Basically, we're going to talk about acids and bases at the end, because I'm going to give the big question I was asked is what's molarity? The other big question was asked is what's pH? So I'll do some examples for those things. Alright? So that's where we're headed. Now I like Arrhenius' definition of an acid. Arrhenius was Danish, 1887. He said, an acid is something that releases H-positive ions in solution. And a base is something that releases OH-positive ions in solution. And it's no coincidence that H plus OH equals H2O, which is water, and there's a scale, the pH scale. Anything less than 7 is acidic. Towards 0 be really acidic. Anything over than 7 is a base. Towards 14 would be really basic, okay? Now, a base will do just as much damage as an acid if you put your hand in it. So you're not going to be putting your hands in these things if you come across them. Weak acids would be vinegar. Let's not deal with the complications yet. I'll give that story in a minute. Acids, they have lots of H-positive ions in the solution. Neutral, water, has equal numbers of either one. Bases have lots of OH ions in solution. That's Arrhenius, okay? Now there are other things, modern definitions, proton donors or acids. I don't care about that, I don't like it. So that's what we're doing. When we come to acids, this is all to do with solutions. It's all to do with solutions and concentrations, because what do we have? You take a beaker of a solvent. H2O is a solvent, you can dissolve stuff in it. Throw a bit of sugar in it, it'll dissolve, right? It makes a uniform or homogeneous kind of substance. You don't see little grains. You can throw sodium chloride into that. That's called a solute. This is only terminology. It doesn't matter. I'm not a chemist. And the H2O is a solvent. Now you might ask yourself, how much stuff is in something? You need to quantify something. So chemists like to use liters for volume. I don't. I like to use cubic meters. I'm a physicist. But we have to stick with their notation. And you have a certain amount of stuff, let's say in 1 liter. Let's say this is just 1 liter. You might ask yourself, how many grams of salt is dissolved in 1 liter? 2 grams in 1 liter would be 2 grams per liter. That is actually concentration. However, you could ask another question. If this is moles, how many moles are in there of a substance? You have to go back to my discussion on moles, but towards the end I will remind you what a mole is. But if you don't even know what a mole is, in this class you will figure out how to do all the problems, right? So we're talking mostly about solutions and their concentrations. Molarity. Now there's some notation here, and I just got my head around it now, so I hope I get this right. Moles. Let's do the moles first. Now let's look at atomic hydrogen. Now hydrogen gas has a formula, H2, it's 2 atoms stuck together. We'll just talk about atomic hydrogen, 1 atom of hydrogen. It has atomic number 1 and atomic weight 1. Atomic weight, atomic number. So a mole of that stuff is 1 gram. How many atoms? .02 by 10 to the power of 23 atoms in any mole of anything. A mold of rabbits, if you have a mold of rabbits out in the field, you have 6.02 by 10 to the power of 23 rabbits in the field. Alright. Oxygen. Atomic oxygen, once again, oxygen gas has a formula O2. I'm just talking about atomic oxygen. Oxygen has atomic number 8 and atomic weight 16, and I'm rounding these off. It's probably 16.1 or 2, I don't know. I'm just rounding it off for the problem. So, mole of oxygen is 16 grams. Here's another way of looking at it. A mole of anything, in the case of atoms and molecules, counts the number of nucleons in there. Right, how many nucleons in oxygen? 16 in one atom, right? Let's do another mole. Carbon. Carbon has atomic number 6, and atomic weight 12. We take it as 12 grams as a mole of carbon atoms. Carbon atoms you don't have to worry about, they do exist as single atoms. Now you can see that mole of anything is take the atomic number and call it grams, right? Uranium. Atomic number 92, atomic weight 238. Mole of uranium is 238 grams. That's the mole. Now 238 grams of this will always have Avogadro's number of atoms in it. You don't have to know why that is yet. You have to get your head around that someday. If you want to get your head around that, go back to the talk I made on the mole. So that's moles, that's where we're heading. And what is molarity? I will write down a sentence as a definition. Now, following that definition, now you can always run it. You don't even need me to work out examples for you, but I will anyway. The molarity of a substance X in a solution is a concentration. It's a measure of concentration. But we're measuring not in grams per cubic meter or grams per litre. We're measuring in moles dissolved per litre, okay? Suppose there are 10 moles in a litre. The molarity is 10 moles per litre. Suppose there's a half mole in a litre. The molarity is a half mole per litre. Suppose there are 4 moles of a substance dissolved in 2 litres of water. How many in 1 litre? 4 and 2, that means 2 per each litre. See? You divide the number of moles by the volume. Now the chemists seem to be using this symbol to talk about the concentration of X. The concentration how? In moles per volume. Moles per cubic meter? No. Moles per litre. Moles per litre. Okay? Now let's look at some quick examples off the top of our heads. 3 moles of stuff dissolved in 3 litres of water. How many moles per litre? 3 over 3 is 1. All right? 3 moles of stuff, X, is dissolved in 6 litres of water. 3 per 6, 3 over 6 is 0.5. Let's write one of those down. Example, 3 moles of sodium chloride, Na, sodium, chlorine, sodium chloride, is dissolved in 12 litres. Now these kind of numbers might not be exact, it's only for the examples. Of H2O, what is the molarity of the solution? Solution, answer. Now I think they use this symbol to denote concentration. Is 3 moles dissolved, where is it? 12 litres. Now 3 over 12 means that there is 3 divided by 12 moles per litre. Go and get your calculator. But I know that 3 divided by 12 is 0.25. Now, as another complication, chemists denote the molarity as M, a symbol M, but really what we're talking about is the number of moles per litre. All right? Now, that's when you're given the number of moles, you can figure it out straight. Sometimes you might be given the number of grams instead. But we'll do another one, but we'll do it in your heads. All right. 40 moles dissolved in 10 litres. What's the molarity? Molarity is 40 over 10, or 4 moles per litre. See? All right. 12 moles dissolved in 60 litres. Yeah? 12 over 60 is, what is it? 12 over 60 is 0.5, no? 1/5, 0.2, sorry. Let's write some numbers down. We don't need these. .2 moles in 4 litres. M. I'll say of X. Now 4 into that goes 0.05 times. In other words, you have 4 litres with this much in it, only this much in 1 litre. And we'll use the notation. Substance X, its concentration is 0.005 moles per litre. Moles per litre, moles per litre, those things mean the same thing. That's molarity. Now let's do something slightly different. Oh, I need the periodic table for this one. Heldman 2. That's not a periodic table, but it'll do. Okay, so I'm going to clean the board and we're going to do it a slightly different way. This time we're going to be given the number of grams and we have to figure out the molarity instead, using grams instead of moles. Actually, I made up an example before. Okay. I made up this at my breakfast. Two liters. Make it simple. Okay, so I didn't make it up the whole way. Now we're given grams. We want to know what is this in moles. Question is find the concentration two ways. First in grams per litre, and second in moles per litre. So for A, we have 12 grams per 2 litres same as 6 grams in 1 litre. 12 grams in 2, 6 grams in 1. That's the concentration in grams per litre. For moles per litre, we need to know how many moles do we have. So how many moles of NaCl in 12 grams? Okay. So we need the atomic weights. Sodium has atomic weight 23. Now, as far as I remember, 35 is what chlorine is. The atomic weight of chlorine is 35 atomic mass units. 23 atomic mass units. Oops. So we just take the atomic weight and round it off. So therefore then a mole of NaCl is these two things together, because there's the whole thing. So 58 grams is 1 mole of NaCl. Now we don't have 58 grams. We have less than 58 grams. How many grams do we have? We have 12 grams. I'll write it clearer. If we had 58 grams, that would be a whole mole. a whole mole of NaCl, we only got 12 grams. Now it's 60, so what is it going to be? It's about 1/5 of a mole, right? So we have about 1/5 of a mole. We'll work it out exactly. So that the number of moles we have is 58. I keep doing this because I keep losing my eraser. 58 over 12 is what? 0.2. So we have 0.207 moles. So for part B, the molarity of this one is this. So we have 0.207 moles for 2 litres, so therefore then the molarity is the number of moles in 1 litre. 0.207 over 2 is 0.1035 moles per litre. And chemists use that symbol M. Okay, now let's do pH. pH coming up. I think I'll do the general discussion of acids later. Actually, I'll stop that one there and make that one class, and I'll do pH next class, so it'll be a separate unit, okay? Because this has gone into almost a half an hour. I'll stop and I'll start again.